Hello everyone! Welcome back to our YouTube channel. Don't forget to like, subscribe, and click the notification button for more interesting tutorials on mechanical engineering. By Professor Photon. Today we are going to delve into the intricate details of milling machines, as they stand out as the most precise machines employed in the manufacturing and production processes. In the next few minutes, we'll embark on a journey to understand the world of milling machines. We'll start by understanding what a milling machine is, explore its key components, dive into the various types available, uncover the inner workings of how a milling machine operates, and finally, we'll take a closer look at the wide array of milling operations it can perform. By the end of this tutorial, you'll have a solid grasp of milling machines and their versatile capabilities. So let's begin with the basics. What exactly is a milling machine? A milling machine is a tool that uses a rotating cutter to shape and cut materials like metal, wood, or plastic. It's often used in manufacturing to create precise shapes and holes in workpieces. Parts of milling machine. A milling machine consists of several major parts, including 1. Base. The base provides support and stability to the machine. 2. Column. The column is a vertical structure that houses the milling machine's main components and allows for vertical movement. 3. Knee. The knee is an adjustable vertical casting that moves up and down on the column. It supports the saddle and table. 4. Saddle. The saddle is mounted on top of the knee and can move horizontally along the ways. It supports the table and allows for longitudinal x-axis movement. 5. Table. The table is the work surface where the material to be machined is placed. It can move in both longitudinal x-axis and transverse y-axis directions. 6. Spindle. The spindle is the rotating component that holds the cutting tool, for example, end mills or drills. It can move vertically, z-axis, and is responsible for cutting or shaping the workpiece. 7. Arbor. The arbor is a shaft that connects the spindle to the cutting tool. 8. Overarm. The overarm is a horizontal beam that supports the arbor and allows it to extend outward from the spindle. 9. Quil. The quil is a part of the spindle that can move up and down independently of the spindle itself. It is often used for drilling operations. The working principle of milling machine. The workpiece is holding on the work table of the machine. The table movement controls the feed of workpiece against the rotating cutter. The cutter is mounted on a spindle or arbor and revolves at high speed. Except for rotation, the cutter has no other motion. As the workpiece advances, the cutter teeth remove the metal from the surface of workpiece, and the desired shape is produced. Types of milling machines. There are majorly 4 types of milling machine, including 1. Vertical milling machine, 2. Horizontal milling machine, 3. Universal milling machine, and 4. Rotary milling machine. It is very similar to a horizontal milling machine in construction, as it has the same parts of base, column, knee, saddle, and table. The spindle of the machine is positioned vertically. The cutters are mounted on the spindle. The spindle is rotated by the power obtained from the mechanism placed inside the column. Angular surfaces are machined by swiveling the spindle head. Horizontal milling machines are identified by their horizontally oriented spindle parallel to the work table. Key features include a rectangular work table, an arbor for holding cutting tools, a vertical column, knee and saddle for movement, and an overarm support. Safety features, controls, and coolant systems may also be present. Differences between the horizontal milling and vertical milling machines. 1. On horizontal milling machine, the spindle is horizontal and parallel to work table, while on vertical milling machine, the spindle is perpendicular to work table. 2. On the horizontal milling machines, the cutter cannot be moved up and down, while on vertical milling machines, the cutter can be moved up and down. 3. On the horizontal milling machines, the cutter is mounted on arbor, while on vertical milling, the cutter is directly mounted on spindle. 4. On horizontal milling machine, the spindle cannot be tilted, while on the vertical milling machine, the spindle can be tilted for angular cutting. 5. On horizontal machines, operations such as plane milling, gear cutting, form milling, straddle milling, gang milling, etc. can be performed, while on vertical milling machines, operations such as slot milling, T-slot milling, angular milling, flat milling, etc. can be performed, and also drilling, boring, and reaming can be carried out. The universal milling machine. The universal mill has the versatility to perform as a vertical and horizontal milling machine. A universal milling machine is different from other types of milling machines due to its versatility and ability to perform a wide range of machining operations. Here are some key differences. 1. Versatility. Universal milling machines are designed to handle both horizontal and vertical milling operations. This versatility allows them to work on a variety of workpieces and perform tasks like slotting, drilling, contouring, and more. 2. Swiveling head. Universal milling machines typically have a milling head that can be swiveled to various angles, allowing for complex machining tasks and the production of inclined surfaces. 3. Table movement. They have a table that can move in multiple directions, longitudinally, crosswise, and vertically. This movement capability enhances their flexibility in machining workpieces of different shapes and sizes. 4. Tooling options. Universal milling machines can accommodate a wide range of cutting tools, including end mills, face mills, and more. This tooling flexibility is essential for various machining operations. 5. Workpiece fixturing. These machines often come with adjustable workpiece fixturing options, making it easier to secure and machine irregularly shaped parts. A rotary milling machine, also known as a rotary table milling machine, is a type of milling machine that incorporates a rotary table for holding and positioning the workpiece. This rotary table can rotate around its axis, allowing for more versatile machining operations. It's commonly used for tasks like cutting gears, spiral grooves, and other complex shapes. Rotary milling machines are valued for their precision and ability to produce complex parts.
Here are some of milling operations. 1. Plane milling, engaging in conventional milling. 2. Face milling. It is the process of milling flat surfaces. 3. Angular milling. It involves precision machining at various angles. 4. Form milling. It involves shaping materials with a milling cutter. 5. Straddle milling. It involves simultaneous milling, two parallel surfaces. 6. Gang milling. It involves utilizing multiple cutters for efficient milling. 7. End milling. It focuses on milling the end of a workpiece. 8. Keyway milling. It involves creating keyways or slots in materials. Plane milling. It is the operation of production of flat surface parallel to the axis of rotation of cutter. It is also called slab milling. Plane milling cutters and slab milling cutters are used for this operation. It can be carried out by both horizontal and vertical milling machines. Operation 2. Face milling. It is the operation performed by face milling cutter rotated about an axis at right angles to work surfaces. Face milling cutter are also used at times to perform this operation. The depth of cut is provided to the table. It is illustrated with the following diagrams. Operation 3. Angular milling. It is the milling operation that involves production of an angular surface on workpiece other than at right angles to the axis of the rotating machine spindle is known as angular milling. Examples of angular milling is production of the V-blocks. Angular cutters are two types. 1. Single angular cutter. 2. Double angular cutter. A single angle milling cutter is used for angular surfaces such as chambers, serrations, and groves. It's all illustrated with the following diagrams here. Operation 4. Straddle milling. It is the operation of production of two vertical surfaces on both sides of work by two side milling cutters mounted on same arbor, by using suitable spacing collars. The distance between the two cutters is adjusted correctly. Straddle milling is commonly used to produce square hexagonal surfaces. It is illustrated by these images and animation. Operation 5. Form milling. Form milling is the operation of production of irregular contours by using form cutters. Machining convex and concave surfaces and gear cutting are some of examples of form milling. The teeth of the form milling cutter have a shape which corresponds to the profile of surface to be produced. It is illustrated by images and animations here. Operation 6. Gang milling. In gang milling, 2 or more milling cutters are mounted on same arbor. Displacing the cutters half a pitch in relation to each other assists in avoiding vibration. Advantages of gang milling: 1. High productivity. 2. High removal rate. It is the operation of machining several surfaces of work simultaneously by feeding the table against number of cutters mounted on the arbor of the machine. This method saves much of machining time and mostly used in production work. All cutters may perform the same type of operation, or each cutter perform different type of operation. It is illustrated with these images and animation. Operation 7. End milling. It is the operation of producing a flat surface, which may be vertical, horizontal, or at an angle to the table surface. The end milling is performed by a cutter known as an end mill. End milling is mostly performed on a vertical milling machine. Operation 8. Keyway milling. It is the operation of production of keyways, grooves, and slots of different shapes and sizes. It can be performed on a milling machine by using a plane cutter, a metal slitting, an end mill, or by a side milling cutter. Operation 9. T-slot milling. In T-slot milling operation, first a plane slot is cut on the workpiece. Then the T-slot milling cutter is feed from the end of workpiece. I hope you have learned a lot from this video. Kindly tap on subscribe button and notification bell to keep this YouTube channel growing. Professor Photon is ready to teach you for free. I pray you don't forget all you learnt. Bravo!